In early August 2025, in a wide-open sector of the front, Ukrainian forces executed a devastating precision strike that stunned military analysts worldwide. A Russian armored column, consisting of advanced T-90M tanks and BMP, 3 infantry fighting vehicles, was moving across a stretch of open terrain. Confident, slow-moving, and heavily armed, the convoy represented decades of Russian military investment. By conservative estimates, the total cost of the equipment in that single column exceeded $40 million. What happened next cost Ukraine less than $200. A swarm of small, fast, and improvised drones, many worth just $3 to $5 in components, was launched by Ukrainian drone operators stationed nearby. These weren't military-grade systems. Their parts were purchased online, the frames printed on 3D printers, and the weapons strapped on with zip ties. The first wave was reconnaissance. Drones quietly scanned the terrain, marked targets, and identified vulnerabilities in the convoy. Then came the strikes. The attack was swift and surgical. FPV, first-person view. Drones dove toward the tanks from the flanks and rear, targeting their weakest points: engine compartments, turret tops, and hatches. One T-90M was hit squarely in the engine bay. It exploded and halted the entire column. Seconds later, more drones swarmed in, delivering precision hits. Each drone carried a modified Soviet-era anti-tank grenade, like the RK-3, transformed into a top-attack warhead. These were dropped or rammed into targets from just meters above, triggering high-temperature shaped charges capable of penetrating even the thick armor of modern tanks. The entire operation lasted under an hour. By the time it was over, at least 7 armored vehicles had been destroyed. Some crews managed to escape. Others burned alive in their cockpits. Ukrainian losses? 0. Footage released by Ukrainian sources showed the chaos from above. Tanks erupting into fireballs, infantry carriers abandoned midfield, trails of black smoke snaking into the sky. This wasn't just a tactical success. It was a turning point, a case study in how asymmetrical warfare, powered by DIY drones, can defeat legacy armored systems at a fraction of cost. The drones that destroyed a $40 million armored column weren't built in military labs. They weren't rolled out by defense contractors. They were assembled in garages, workshops, and sometimes basements, using parts anyone could order online: motors, battery packs, flight controllers, video transmitters, all civilian-grade components originally intended for hobby drones or racing kits. The frames were often 3D, printed from plastic or carbon fiber, tailored for speed and agility. The cost? Between $3 and $5, not counting the warhead. And those warheads? Most were repurposed RKG-3 anti-tank grenades, Cold War relics pulled from old Soviet stockpiles. With a bit of ingenuity, Ukrainian engineers adapted them to attach securely to drone frames. Dropped from a few meters up or slammed into targets from above, these grenades still pack enough punch to destroy engine blocks, ignite ammo compartments, or rupture fuel tanks. Control is fully manual. Each drone is flown using a video headset, transmitting real-time footage from an onboard camera and guided by a joystick or even a modified gaming controller. Many of the pilots aren't soldiers. They're coders, gamers, students, and IT professionals. Civilians with quick reflexes, spatial awareness, and nerves of steel. Most go through just 3 to 5 days of training before deployment. They're taught how to fly under pressure, how to navigate by terrain, how to adapt mid-flight. And that's what makes this so revolutionary. Instead of relying on a massive, bureaucratic military-industrial machine, Ukraine has created a decentralized, grassroots drone army. Dozens of operators, hundreds of printers, thousands of flight hours logged by civilians who were never meant to be at war. Each operator customizes their drone. They adjust the balance, upgrade the camera, reinforce the mount, modify the software. Nothing is standardized, and that's exactly the point. Adaptability beats rigidity. Speed beats tradition. These aren't mass-produced weapons rolled off an assembly line. They're improvisations, each one uniquely crafted to respond to a dynamic battlefield. And when one drone is lost, another can be built in a few hours, from plastic, from code, from the hands of someone who might have been a student or software developer just a year ago. This is the future of warfare, agile, affordable, and terrifyingly effective. Russian armor vehicles like the T-90M and the BMP-3 are designed to survive on modern battlefields. They're equipped with composite armor, explosive reactive blocks, and active protection systems meant to intercept incoming missiles before they strike. But none of it worked. And the reason is simple. These defenses were built for old threats, not for $3 flying bombs that come from above. The T-90M, for example, is heavily protected on the front and sides. Its armor is thick. Its reactor plates can deflect shaped charges. But its roof? Still vulnerable. That's the blind spot. Most tanks are built with the assumption that attacks will come from other tanks, artillery, or anti-tank missiles. Not from above, not from drones the size of a shoebox. Top attack is the new battlefield meta, and most Russian vehicles simply weren't built to survive it. The drones fly low, fast, and unpredictably. Their small size and speed make them nearly invisible to radar and optical systems. By the time a tank crew spots one, it's already too late. The drone dives, hits the turret roof or the engine compartment, and explodes. Active protection systems? They fail. Why? Because they're optimized for large, predictable threats, not tiny drones zigzagging just meters above the ground. Most of these systems can't even detect such small aerial targets, let alone intercept them in time. Electronic warfare? It's supposed to jam drone signals. But Ukrainian operators use rapidly changing frequencies, hobby-grade transmitters, and even commercial platforms like Starlink for uplink redundancy. Russia's jammers simply can't keep up. And there's another flaw in Russian doctrine. Their vehicles often move in tight formations, good for defense against ambushes or mines, but terrible when facing drone swarms. One disabled tank can block an entire convoy. The rest are forced to stop, making them easy targets. A jammed-up column becomes a graveyard. Some crews try to flee. Others abandon their vehicles entirely, fearing a second wave. But the drones are faster than they are. Camouflage nets? Paint? None of it matters. Ukrainian drones use high-definition cameras and thermal imaging. They see through brush, through shade, through darkness. This is asymmetry in action. A tank worth millions is helpless against a plastic drone, controlled by a kid with a VR headset and a joystick. The cost-to-kill ratio is insane. And that's why the Russians are losing hardware faster than they can replace it. It's not just a tactical defeat. It's a design failure, a strategic blind spot exposed by a tool so simple it feels absurd. But the results are real. Columns burning, soldiers fleeing, and generals scrambling for answers. What we're witnessing isn't just a series of successful drone strikes. It's a complete redefinition of how wars are fought. The battlefield has shifted from heavy machinery to lightweight code, from centralized command structures to decentralized improvisation, from billion-dollar budgets to basement-built bombs. Ukraine's drone program didn't begin in military labs or government offices. It began in garages, in dorm rooms, in Telegram groups filled with engineers, gamers, and volunteers. Now, it has become one of the most effective battlefield forces of the entire war. Why? Because it scales. One drone is a tactic. A dozen drones is a skirmish. But a swarm, launched in coordinated waves, controlled remotely by civilian-trained pilots, supported by real-time satellite data, is a weapon system, a battlefield doctrine, a strategy, and Ukraine has turned it into a production line. Every loss is analyzed. Every drone is improved. Frames are redesigned. Cameras upgraded. Balance adjusted. There is no bureaucracy. No delay. Just adaptation and speed. While traditional militaries take years to improve new weapons, Ukraine builds, tests, and deploys in days. Operators train in 5-day boot camps. Printers run 24/7. Old Soviet munitions are given new life as precision payloads. And civilian donations, crowdsourcing, and open-source software keep the system alive and growing. This model is now being studied around the world because it's working. In just a few months, it has forced the Russian army to change how it moves, how it defends, how it thinks. It's exposed weaknesses in billion-dollar systems and rewritten the rules of armored warfare. For Russia, it's a nightmare. For the world, it's a glimpse into the future. The next generation of combat may not be decided by who has the most tanks, missiles, or ships, but by who has the fastest coders, the smartest engineers, and the most adaptable tactics. War is becoming decentralized, and the most dangerous weapon on the battlefield is no longer the most expensive. It's the one you don't see coming. Because somewhere in the garage, a 19-year-old with a laptop and a 3D printer might be building the next drone that changes the war. Again, this isn't science fiction. This is real. It's already happening. And it started with a $3 drone and a $40 million mistake.